In today's video, I'm going to show you how to wire a receptacle or an outlet, as some people will call it. In this situation, we will be swapping out this nice white 20 amp with this kind of beige tan color. And this isn't going to show you how to actually run the wire in the wall, but it is going to show you how to physically wire the device itself. So let's get to it. To start this project off, let's go over any tools you might need for this job. You're going to want some sort of voltage tester or meter. You're going to want a non-contact voltage tester. You're going to want an outlet tester. You're going to want some form of screwdriver. Probably going to want some sort of diagonal cutters. You're going to want some wire strippers / pliers. It doesn't have to be a multi-in-one. I just use this one because it's really high-end and I use this daily, so that's why I have this. But a simple needle nose pliers will work, and wire strippers. You're going to want some quality electrical tape. This is Super 88. You're going to want Wagos, especially if you are a DIY homeowner or new to electricity. I highly recommend Wagos. They're not an absolute must, but you're going to need some sort of wire nut. But spend the money, get the Wagos. They make your life easier. They make it safer. And then, of course, you're also going to want your receptacle. Now, I'll link to this video, a safety video, in which I go over how to actually ensure properly that the power is turned off, but I'll do a basic overview in this video. If you have any questions though, click on the attached video and I'll show you how to safely make sure power is off. To get started, plug in your outlet tester. You know it's on. Go over to your panel box and shut that breaker off. Now that my power is off, we know that because the lights were out, I'm going to go ahead and remove my faceplate. Get your non-contact voltage tester, ensure it still works. Try to stick it in on the side. Stick it in a hot. It's not beeping. Test it again. We're good. So now you're going to remove the existing device, and you're just going to grab what we call the yoke. This part is grounded, so we're going to pull it out. And we're always going to treat it like the wires in there could still be hot, because in this situation, we have access to the wires, right? This is just a demonstration to show you how the wires are landed. But in your situation, you might have multiple wires coming into this box that are unassociated to the circuit tied to this device. Meaning you may have shut off the power to just this, but there may be wires in there that are still hot and could electrocute you. So always proceed with caution. This is where I like to get our non-contact voltage tester again. Test it. Try to touch every wire in there. Make sure it doesn't beep at all. Beautiful. Test it again. Turn it off. Now in this situation, there is electrical tape wrapped around my receptacle, but this isn't always going to be the case. There are screws under here, so proceed with caution. They could still be live. Unwrap your device if it has electrical tape. If not, hold off to the next step. Now, if I were to turn the circuit breaker back on, the sides of my receptacle would be energized. So, to ensure that we know that this is dead, power is off before I touch it, I always like to use my multimeter or tester. Put it onto the voltage mode, make sure it's AC. That's the V with the squiggly line. This one does both, but it's the V with the squiggly line. Touch black hot to ground, which is that green or bare wire. I have 0 volts. Touch hot, which is the black, and the neutral, which is the white. 0 volts. And lastly, touch neutral to ground, 0 volts. So we know we can touch this with our hands safely. I'm going to remove my mud ring, but in your case, you might not have a mud ring. Electrical boxes come in all shapes, sizes, different forms, but the wiring is still going to be essentially the same. Now, you can see in this case, this was already pre-wired with these Wago wire nuts. You, if you are doing a remodel, might not have that luxury. That's okay. We know that these wire nuts, which we can visualize with our eyes, we can see that these wire nuts are going to this device. You know, there might be more in here. Don't touch those if they're not going to this device. These are the wires we tested. We made sure they're off. But if you have the older style twist-on wire nuts on there, you can simply cut them off. If they're in string, there's no power. You'd strip, and you'd get them ready for these Wagos. I'll show you why they're so great. They just simply come off. Boom. Okay. So now there's no device attached. But if you have a series of receptacles, you have one here, something further down the wall, you're going to have your hot, you're going to have a neutral, and you're going to have a ground coming in, and then coming out, you're going to have a hot, a neutral, and a ground. You may be wondering what this is. This is called a ground bonding jumper, and they are actually required whenever you have a metal box. So if you have a metal box, they look like this. They have a little ground screw, green, and it's like a pigtail. And it goes into the back of the box and bonds the metal box to the ground grid system. Now, if this is the last receptacle in line, like this one, there is not going to be any out wire. There's only going to be the left in wire. You'll notice on a receptacle that there are 2 screws. You can put one set of screws on top, one set of screws on the bottom, one set of screws on top, one set of screws on the bottom, and then the grounds to the green. However, the way I recommend every homeowner and every electrician I've ever worked with, the way I recommend to them, which I think is the most reliable and safest option, is to do the jumper method. Get yourself the Wagos, strip your hot, strip your white neutral on both of them, and you're going to do white to white, black to black. So I have both sides stripped. I use my wire strippers. I use my Wago. It has a strip gauge on the kit actually, so you don't want any exposed conductor hanging off, but you simply strip it, slide it on, close the lever, it's safe. So let's do the neutrals, which are white. Hot is black. Connect my in and my out. And lastly, I'm going to do my ground. Now, because I have a ground bonding jumper, again, only because this is a metal box, I'm going to use the 5 conductor Wago wire nut. You notice that there's exposed conductor on this ground. That's fine, because it is the ground system that's the only conductor in here that you can have exposed. How do we get the power off of these wire nuts onto our device? Because right now, all we did is we tied white together, blacks together, and our grounds together. So this guy has power, but we don't have anything to the receptacle we're going to put here. That's where our jumpers come in. Get yourself some Romex. In this case, because I have 20 amp receptacles, what tells me that this is 20 amp is because it has that little side slot, and because I have a 20 amp breaker. A lot of people are going to have 15 amp receptacles, in which case you should have the white, it's not always going to be white, but usually it's the white 14 gauge Romex or NM type cable. So make sure you have the appropriate size cable for the job. 20 amp goes on 12. 14 amp, which is just the regular looking outlet, that goes on, or 15 amp, sorry, goes on 14 gauge. So cut yourself a small piece of Romex and pull out the cable. I like to use my wire strippers. Pull it out. You're only going to need about 6 inches. So cut it to length and strip it. This is 12, so I'm using the 12 amp side. And you put it in your jumper. There you go. This is what's going to go to the device. Next, I have my neutral. Again, about 6 inches is all you need. Strip both ends. And attach it to your Waco wire nut. Lastly, you're going to want to do your ground. 6 inches again. That's going attached to your ground. Okay. Now you can kind of go ahead and shove a lot of this back into the box. Give yourself some space. You can see these 3 pigtails that are going to go to your device. Now you'll notice on your device, you're going to have brass, which is hot, brass to black, silver, which is going to go your neutral, so silver to white, and green to ground. Now, these are nicer Eaton receptacles. Don't get the cheapo Home Depot, big box store, whatever option. I really don't like using the 89-cent or the $1 receptacles. This guy didn't break the bank, but it's of a much higher construction. The thermoplastic doesn't fall apart, and it has these really awesome screw holes where I can just push the wire in and then tighten it down. Whereas the method of the cheaper end receptacles, you have to actually put hooks on each one of the screws you use. So in this method, I'm going to show you how to just stab them in the back and tighten it down. So grab your screwdriver. Remember, black goes to brass. So it's tight, shove that in, tighten it down. Make sure it's really snug, it's not going to go anywhere. Tighten down both screws, top and bottom. That way it's not wiggling and rattling around every time you plug something in. They have a strip gauge. Make sure you don't have too much exposed. You can see this would have entirely too much exposed conductor, so I'm actually going to trim that up. White goes to silver, which is our neutral. Again, just a reminder, you're of course only doing this on a confirmed dead circuit. You do not ever do this on live circuit. 120 has hurt and killed many people. You don't want to become a statistic. I don't say that to scare you, just you have to respect it and use caution. Cool, now we have to do our ground. Now the ground on this specific type of receptacle, it doesn't have that awesome little push-in screw port. We have to actually loop our wire, which is no problem. Simply grab your needle nose, or in my case, I have my multi-Knipex electrician pliers, which I love. and you're going to make a loop. See, it's kind of like a J. Now what's really important is when you attach your loops to the screw, you have it facing the correct way. So you can see my hook is facing to the right around the screw. You want to be able to have it facing clockwise so that when you tighten it, righty-tighty, this grips and closes tight. If you have it facing the other way, when I screw clockwise, this hook will actually open up and might have a bad connection. So always have the hook facing towards the right around the screw so that when you tighten it clockwise, it tightens up. So press that screw on, and I like to just give it a little squeeze with my pliers, tighten it up. Nice and tight, it's not going anywhere. Perfect. Now, get your Super 88 electrical tape. This is only a little bit more expensive than your really cheap off-brand, but don't skip out on the electrical tape. It's worth it in the end. So this stuff is good in 0 to like 200 degrees. It's great. Use it on all my devices. Prevents possibly having things get stuck behind and touching the side screws. And if you ever work on it in the future, it makes your life easier. Pull it off. Perfect. Now, I like to shove my wire nuts in the box. It's okay, you gotta use a bit of force, especially in a house. This is going to be solid wire. It's not gonna be stranded. Now, orientation, according to the NEC, there is no correct orientation. Some people put the ground screw up, some people put it down. I like either or. I prefer ground screw up in most situations, but I know most people are probably going to be used to this. Next, if you have a mud ring, this is for metal boxes only. You're going to put your mud ring on. There we go. But if you have a plastic box, you are probably not going to have a mud ring. Now, you're just going to tighten up your screws on your device. Okay, now that it is square with the box, we're going to go ahead and we're going to put the faceplate on. Now, personal preference, I like to keep the screw perfectly up and down to know that I was the last person to work on it. If you have somebody who's sloppy with the work, they might have it cockeyed like that. I think it looks bad, so I like to keep it straight up and down. Now that it's like this, go back over to your circuit panel and turn the circuit breaker back on. Now that power is restored and the circuit breaker didn't trip, it's important to go ahead and test it with your outlet tester. The two lights turned on. This one is great. Most of them have these little color codes that'll tell you if you put the wires on the wrong side of the device. Highly recommend one of these. Put it on the top, both lights are on. Put it on the bottom, both lights are on. We're good to go. And then the last and final step is I like to go ahead and test it with my voltage tester. Make sure that I have roughly 120 volts. And I do, both the top and bottom. So with that, that concludes the project. Thanks for watching today's video. I hope this helped teach you something, and make sure you check out my other videos. I have a really good safety tutorial video that I've attached to this video. Make sure you watch that before starting this or any other electrical project. And if you have any comments, make sure you leave them down below. Make sure you like and subscribe, and I'll see you in the next one. Thanks for watching.